Sounds good. Okay, so the assignment 2 is due February the 10th. That is 10 days after now. So it will consist 2 parts of this assignment. And the first question is a programming question that is basically you want to brute force a pre-image for a MAC address using SHA-5256. And for question 2, it's just a simple answer question about the forward secrecy of kerbals, like what are the long terms, what are the short terms, and for each secret, blah, 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 and explain why it doesn't have forward secrecy. So for this one, it's very similar for what you would see. Well, actually, you already seen in question 1. Sorry, in assignment 1. So you basically just follow the same idea, explain things well, and make sure you describe your solution in a clear and concise way. So yeah, we don't have much to talk about question 2, and the only thing you have to know about question 2 is you actually submit your solution for question 2 through Gradescope again, and I think it is up for all of you. And yeah, it's either through Gradescope or the protest. And for the protest, that is the question 1. So for question 1, what we expect you to do is to brute force the pre-image of a hash result. So what does that mean? Well, the first thing is you have to know what is a MAC address. So for a MAC address, this is basically an identifier that is assigned to hardware manufacturers like network cards or Bluetooth cards, things like those. All those cards, they have a MAC address that is the unique identifier for that hardware. And a very typical MAC address consists of 6 bytes in binary. And because in computer science we don't write binaries out; it's just too long to write. We usually use hexadecimal to represent binary numbers, because one hexadecimal digit represents 4 bits. So 2 of them will be 8 bits. That is a byte. So that means each 2 digits of this numbers is a byte. So if you count it, that's 1, 2, 3, 4, 5, 6. That's 6 bytes. And because a MAC address is actually in binary form, so this 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. These are the ASCII representation or character representation or string representation of a MAC address. In your solution, we are expecting you to compute your hash value by using the binary form. So you don't want to compute the 0, 0, 1, 1, 2, 2, 3, 4, 5, 5, because if you do that, let me just show you quickly what will that happen. That would, well, if I cat this 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, well, actually should echo this into a text file, and then I'm gonna use SHA-SUM. I think by default is SHA-1, right? Yeah, it's SHA-1. So I want to use the 256 and compute the SHA-SUM, which is the text file. You see, this is very different from what we expect you from doing it, because we are expecting you to take the hash of the binary, not the ASCII form, not the string form. That's why we want you to declare a character array. So for a character array, each character is exactly 1 byte in length. So because this is a 6-byte binary, that means we need 6 characters to hold this MAC address. That's why we declare it as the size of 6. And then you see we have this 0x to indicate this is a hexadecimal representation of a binary. We are not assigning characters to them. We are assigning binary values to it. So once you have all the binary values assigned, then you can compute the SHA result using this function provided over here. So you can just copy and paste and reuse this part of code into your solution. It's perfectly fine. And assume you have this function copy and paste from here, and then you have to include this header file from OpenSSL library, and don't forget to link the crypto library when you're compiling it using the GCC or G++. And then if it compiles without an error, you should have exact same hash value for this binary MAC address. And just to make sure you are getting the correct one, we actually have another one for this hash. For this MAC address, you should have exactly the same hash value that we expected. So these two are just for you to check if you're implementing it correctly. Once you have the correct implementation, then you can start working on brute forcing the pre-image of this MAC address. So what are we trying to ask you to do is, so a MAC address consists of 6 bytes of binary digits. And what about I only give you part of them? Like, for example, you only know the last 3 digits of the last 3 bytes of a MAC address, and I don't give you the first 3 bytes. And at the same time, I'm also giving you the hash value of that MAC address. And then it's your job to find out what are the first 3 bytes that can give you the exact same hash value. And it doesn't matter if it's the first 3. It can be any 3 of them. So make sure your program can take arbitrary missing parts. And this is been so for question 1, this has been submitted through a web server called Protest. So if you copy this link and go to the website, then you will ask for your student ID. After you enter your student ID here, you click submit. Then you will have and then you will ask you for a authentication. And I think that the username is your UCalgary email address without the @ucal.ca. And then your password is a field entry in D12. So I think everyone has access to that as well. If you don't know, then probably you need to check your D12 again to know what are the password for the submission. And just follow the instructions in the Protest and submit your answers through Protest. Only the last submission will be recorded after the deadline has reached. And yeah, I think that explains everything about question 1. Any other question regarding to those? So from what I understand, we take the MAC address, which is a hexadecimal number, convert it into binary, and then pass that binary functor into the chunk. Yeah, exactly. That's true. Any other questions? And you're welcome. Well, so just to make sure everyone understands this part, if you are passing in a character to this array instead of passing the binary form, you will get very different hashes. You will probably get this hash over here. So if you compare those, the correct hash is 48F4, but for me it's 4CA0. It is very different. Even they looks like they are the same thing. Like if I show the content of this text file, it's 001122334455. It's the same thing, but it's not. No, we're expecting you to take the hash of the binary form. All right, I think that explains everything about this assignment. So hope everyone can start it early. And if you have further questions, feel free to drop in an email or ask me during the tutorial. Or anytime you can just post your question and do the discussion board. All right, so let's just finish what we have left last time. So I think we have covered those. Did we cover the? Yeah, we have covered the subnetwork. Okay. So from last time we stopped, we are about to talk about the private IP addresses. So last time we mentioned about the IP address, the address space is huge. It's either 2 to the power of I think it's 8 or no, I don't think it's 8. Whatever. It's just a very big address space, and that means we can divide the whole address space into subnetworks. And there are some subnetworks that has very special purposes, like this one, like the private address spaces. So the private address spaces were originally defined to assist in delaying the v4 address exhaustion, because even we have that many addresses available, it doesn't guarantee that every single device can get a unique IPv4 address. But that is not a problem in v6 because v6 has dramatically improved the address space in size. But it is a serious problem in v4. That's why we have came up with this idea that we declare some very special subnetworks and we treat them differently. So if you can look at the table, we have actually 3 different subnetworks. It is a 24-bit block, 20-bit block, and 16-bit block. So this how many bit block basically says how many addresses we can use. So if it's a 24-bit block, that means we have 2 to the power of 24 addresses can be used, can be assigned. And the special thing about those private address blocks is they don't get routed on the public internet. So what does that mean? So for example, I think everyone at home has their home router or their Wi-Fi router. And your Wi-Fi router actually does 2 things. One is a routing functionality, and one is a switching functionality. So for switching, that basically says if we have multiple devices that is physically connected to each other, they can talk to each other, and that is what we meant by switching. But by routing is a higher level operation that is based on some protocol like IP protocol. I am going to route this packet or route this request to a specific host or to a specific destination. And when I'm saying the private address cannot be routed through the public internet, I'm saying that if you are, let's say you have a PC at home and your PC gets an IP address that is assigned by your home router, and you probably will have a very similar address that looks like 192.186.1. blah blah blah. So that is your private address within your home private network, and that IP address can only be routed inside of your home network. Like if you have another laptop, then you can talk to your PC by using that internal IP address. But when you are using this IP address outside of your home network, nobody can understand where is that IP address and where that came from and where should they be routed to. So that brings up another question: is how do we use this internal IP address to communicate to the outside? Well, there is another technology that was developed at the same time when we declare some part of the subnetwork were being used as private addresses. That is the network address translation. So what does the network address translation do is it basically shares a public IP address to all computers within a private network. So just imagine the same thing. You have your home network, and then you have multiple devices connected to the router. That router will be assigned with a routable public IP address, and then all the other devices connected to this router will share that public IP address when accessing outside of your private network. Like take an example of this picture over here. I have a host that is inside of my home network. It has the IP address 10.0.0.1 and is directly connected to my router, to my home network router, and that router has a public IP address 150.150.0.1. That's a public IP address, and then that router is connected to the internet and other routers and other switches in the internet. And finally, you are trying to do some communication with the server that has the IP address 200.100.10.1. So imagine you are the host and you want to send a packet to the server. So the packet all the packets will have a source IP and a destination IP. Because you are the host, that means the source will be you. So you'll fill in your source IP, which is the private IP. It started with the 10 point something, so that's your private IP. And for the destination IP, that is actually the public IP of the server. So you just fill in those fields and pass it to the router, and the router knows we are actually running inside of a private subnetwork. So the router will do this network address translation for you. That simply just replace the source IP with the public IP that router has, because the router is the gateway that connects to the internet. That means if anything gets sent back to you, they should send back to the router, and then the router will handle the other things inside of the private network. After the router has exchanged the source IP with the public IP address, the router will just send the packet out, and this packet will eventually arrive at the server side. And when a server acknowledges this packet and try to respond with some replies, then the server doesn't know your internal IP address. It only knows it comes from this router. So the server will fill in the source IP as himself, which is the 200.100 public IP address, and the destination IP will be the router, and in this case that is 150.150, right? So the reply will be sent to the router first, and the router will examine, well, this is actually came from the server, and that server was talked with, well, there is a client inside of our private network that has talked to this server before. So this packet must be that guy. So this router will just replace that destination IP from the router to the internal private IP address, and then send it back to us. So you may wonder what is actually being used to identify which packet belongs to which packet. Well, there are actually many different types of network address translation, but one of the very one of the very commonly used one is to bind the source, the IP with the port. So that means if I'm talking to the server with my IP with the port, then anything that comes back with into the same port will be forwarded to me. And if you're interested in more about how this network translation process goes and what are the other types, you can always Google it. So it's network translation table. So you see, we actually have some full CONNET, address restricted, port restricted, symmetric. So this will gives you an idea of how different types of net will handle this case differently, and depends on your use case, you probably can set your router to different modes so that this will achieve some kind of communication that you want. Because if there is a very serious problem with this technology, that is all those network address translation, this actually depends on some state. And that state is the host must initiate the connection first. That means if one of your hosts is being used as a server and there are some other hosts on the public internet trying to access your server, but your server is actually behind the network address translation. This, if you're still using the port, if you're still using the one that I described, that specific mode, it is not routable because we just don't know which port does this port assign to which host does this port is assigned to. So you may want to change your NAT address, your NAT mode into others, or maybe just use the DMZ to fully expose one of the hosts to the public internet. But that is a different topic, and if you're interested in that, you can read that Wikipedia article about this. And and for now, you have to know that those 3 IP addresses, they belongs to some kind of private address space. And for them to, so if you are required to do some monitoring on those packets, you also have to know how this network address translation is going, and which packet belongs to which host, and that should be enough. Questions regarding to those? I think take that as a yes. All right. So for the next part, I think we have mentioned about port numbers. And for a port number, it's basically a 60-bit unsigned integer that identifies a specific process or a type of network service. Like, for example, HTTP services usually runs on port number 80. And the secure version of HTTP usually runs on 443, and the secure shell or SSH usually runs on port number 22. And those numbers are actually chosen by the developers of those protocols, and you can change them easily without any hassle just by changing the number in the configuration file. But when we're talking about the standardized or the well-known services, those are the default ports that we expect when we want to use some services that is being provided on the internet. For example, if you use your browser to access Google, your browser will definitely try the port number 80 first, and then for some cases they probably want to use the 8080, that is 8080, that is also another port number gets assigned to the HTTP protocol. And if you're interested in that, there is a link that is published by the IANA, which is an authority that defines what are the service name and what are the transport protocol port number they are assigned to. Like, for example, we have some. Oh, by the way, the port number 0 is reserved. nobody can use them unless they have some special use cases, but it's not for you, and also not for the applications. And yeah, see, those are pretty much gave you the idea of what numbers are. No, so what are those port numbers being used by some famous services that is provided on the internet? And keep in mind, both TCP and UDP use port numbers. You may take this as both TCP and UDP has the idea of using this port number, but that's partially true. What do I really mean about this is both TCP and UDP, they have their own port numbers. So, for example, the HTTP server, the HTTP protocol, it is actually a TCP protocol. So that means, ideally, HTTP server should only listening on HTTP port number 80 and shouldn't be listening on UDP number port 80. But in practice, when we are developing a network software, when we are developing a server software that uses some network stuff, we actually listening on both. This is just ensure that if some of the clients that cannot use TCP, they can use UDP. But the truth is, even we are listening on the same port number, they are still two different things. The port number of TCP 80, if you're accessing a service using port number 80 by using TCP, that is the TCP port number 80 you're using, not the UDP port number 80 you're using. So you can technically having the same port number assigned to different services as long as they're using different protocols, like one use TCP and one use UDP. And another thing you have to be very careful about when using port numbers is the first 1024 ports are reserved for well-known services, and if you want to listening or if you want to bind some of those ports with your program, that actually requires some special operating system privileges to use. Like, for example, if you want to use the first 1024 ports within a system on Linux, you basically have to run your program as root. Otherwise, there's no way you can use the first 1024 ports. So that's why all of your assignments, well, in the future, your future assignments will be listening on a larger port numbers, like greater than 10,000. So that doesn't require any special privilege to listen. The next topic would be byte order. So for byte order, this basically says how do we want to store our information in a computer system. And there are two byte orders of them. One is big endian and little endian. So think about this byte order as the read or read direction. Like most of us reads from left to right, but there are some languages they just starting from right to left. So it just we cannot say which one is better, but it's just the way they choose, right? They just choose that way to interpret it, and this is exactly the same thing in the computer systems. And imagine we have a 32-bit integer. So this 32-bit integer is in binary form, and it has 4 bytes, 0A, 0B, 0C, 0D. On a big endian system, we actually started from the lowest address in memory, and then increased that address to a higher address. So that means the first byte of this 32-bit integer will be stored on the lowest memory. So in this case is A, and the next byte will be stored on a one byte higher memory, so which is A plus 1, because in memory the smallest size of the unit is a byte, so we just use a+1. That means next byte. Next byte will be stored in a higher level, in a higher address, and then also followed by the next one. So, and the last byte will be stored on the highest. Will be stored on the highest address. So that is basically what big endian means. And for little endian, everything just reversed. We're starting from the highest, which is a+3, and then we decrement that address to a lower address. So that means the last byte will be stored in the memory with the lowest address. Because of the nature of this byte order, the byte order of a computer or a host can be different. And for x86, which is the Intel or AMD CPUs that you can buy from the market, they use little endian. And for portable devices like mobile phones or tablets or maybe the Apple's ARM laptops, those for ARMs, these are configurable. That means it depends on the manufacturer. The manufacturers can set their ARM structures to little endian or big endian. But from my experience, both of the ARM structures, they use the little endian. They don't use big endian. So why do we care about big endian? Because network uses big endian, and that is not fully true because not all protocols use big endian byte order. Like for example, the server message block. The server message block is sometimes referred as Samba, or as known as the file sharing services in Windows. This protocol uses little endian byte order. So it depends on the protocol we are talking about. The end list is actually different, but you may assume the default end list for network protocols are big endian. So because you see, the host end list versus the network end list, they can be different. So that means we have to convert them into a same byte order before we can further processing them. So to convert byte order, there are a set of functions you can use. And those set of functions, those are two-way functions. You can convert it from host to network byte order. So it doesn't matter if your host uses little endian or big endian. It just converts that host byte order into the big endian by using host to network function. So that means that is exactly what this function name is for. So HTON means host to network. We take the initials of the host and network. And there are two different units we can convert, which is a short or a long. For a short, that means we are converting 2 bytes at a time. For long, we are converting 4 bytes at a time. Why is it 2 bytes? Why that is 16 bytes? Why is 4 bytes? Why is 16? That's 16 bit. Why is 4 bytes? That's 32 bits. So it is enough for us to convert those things in for when talking about networking. When we are doing something in networking programming, and because we have the host to network, we also have the network to host. So we just reverse the order of the initials. Instead of using H2N, we use N to H. So that means network to host. So just like the same thing, we have two different types. You can convert a short or a long, depends on your use case. The last thing we need to talk about in network programming is the client-server model. So a client-server model, this basically defines how the servers and the clients how they communicate on the internet. So it describes a structure that partition tasks between the providers of the service, or we call it servers, and the requesters, clients. And the exchanging model of this client-server structure is a request and response pattern. So take an example of HTTP protocol. HTTP protocol is a very standardized, is a very commonly used protocol that takes this client server idea. So every time you use your browser to visit a website, it is actually your browser that sends a request to the server, which is an HTTP request, and then the server processes the request and send a corresponding response with it. If, like for example, if you are visiting the homepage of a website, then the server will just reply with the HTML file with the home page. If you're accessing something that doesn't exist on the server, then the server will just respond with a 404 not found. So that's a very classic client server model when using this request response pattern. So this basically describes what the server do when you're programming a client server model server program. So what does the server do is the server will first find some ports, because that is the port number will be identified or will be associated with this service, like the port number 80 is associated with the HTTP service. After you have binded yourself with that specific number, then you just wait for someone to initiate a connection. If someone has initiated a connection, then you accept that connection. And then after the transmission has finished, you have to process or handle the request. Yeah, you probably need some, you want to extract something from the request. And then based on the extracted request, you want to reply with the corresponding response. And then after the response is been delivered, you can just safely close the connection. So that means both sides, both the client and the server, they must follow the same rule or same protocol to communicate, and that's exactly what this HTTP protocol or SSL protocols are used for. And for a client server model, the server is always waiting for a new request. The server never makes new connections, or the server never initiates new connections to the client, because this is how we define a client server model. If your server is initiating a connection to the client, then that is not a client server model. So keep in mind that the server is always passively waiting for new connections, and it is the client to initiate new connections to the server. And that also means the client can disengage at any time. I can quit this communication when the server is still processing my request, right? And that is one downside of the client server model. And because of the clients can always disengage, this actually becomes one of the very frequent or very, very commonly seen attacks on the internet, which is the denial of service or DOS attack, or you may have heard of the distributed version, the DDoS attack. So what about this DDoS attack? You just have a bunch of clients send a bunch of requests to the server, and after you send out the request, you just disengage. You don't really care about if the server responded to you with some valuable or meaningful information. You just want to waste the server's memory. You just want to waste the server's CPU by sending a lot of requests to the server. So this is why there are some downsides of this client server model, but still it is a very robust and also very easy to understand model when developing code in networks. And that is everything we need to cover today. So I think last time I said I would not be covering the actual programming part. So if you go to the BJ's networking programming guide, so we have covered those part. We have covered the basics of the basic knowledge of networks. So you know what is a socket, you know what are the IP addresses, you know subnetworks, you know the port numbers, you know the byte order. And for this course or for this class, you can safely ignore those V6 ones because we don't use them in either the assignments or the test. You will not see V6 related questions on those, but you still need to know the difference between IP addresses version 4 and version 6. And for the actual programming part, like the structures being used in network programming or in the network libraries and the system calls you can use from the network libraries, I think this part, it is best for you to learn it by yourself because it is fully described. This is a very complete guide about how to use those system calls and how to use those structures when using those system calls. You see, we're actually using some custom structures when using those system calls, and these structures are being described in the first few chapters. So you can learn that part by yourself, because if I teach those things to you, then I'm just gonna repeat the same thing what he says over here. It is waste of time for everyone. So hopefully everyone can learn this self by yourself. And if you have any difficulties understanding some ideas of them, feel free to drop me an email or just ask me a question or just post a discussion on the discussion board in D2L. And don't forget, your goal is to understand all the basics plus the programming knowledge of the socket programming, and your goal is to write a simple stream server and client. And I think you will be using those knowledge in the next assignment, because for assignment 2, the programming part, you just want to write a very simple brute force program that gives you the answer of the question 1. But I believe for assignment 3, there will be something related to the socket programming. So be prepared and study this or learn those by yourself early, as soon as possible. And that's everything we need to cover today. And thanks for coming. Happy Chinese New Year. And I will see you guys next time. If you have any questions, you can stay. If you don't, then you're free to go.